Good morning, everyone. I'm Lena Maier-Hein from the German Cancer Research Center, and this session is all about MICCAI challenges. So I will actually start talking about the MICCAI board activities with respect to challenges, and then I will hand over to my colleague Annika Reinke, who is the chair of the 21 team on challenges. So what are we doing? Many of you may know that organizing a challenge is actually a lot of work. A lot can go wrong. And our mission is to support the community in organizing good challenges. We more or less want to create or pave the way for the next generation of biomedical image analysis challenges. It's a lot of work, so it really requires a team effort. And I'm very honored to work with this amazing team shown here. We started as a working group of the MICCAI board, but this year, this working group has been converted to a so-called MICCAI special interest group. One reason being that we want to connect to initiatives, to societies beyond MICCAI, because we really think that we should make this a worldwide effort. So it all started actually with our structured submission system. This was a collaboration with the MICCAI 2018 team, where for the first time we acquired the challenge design in a structured manner. We did this to basically create a system similar to a review system for papers, because we think that the impact of an individual challenge is probably on average greater than the impact of a paper. So we think that we need a peer review process to review challenges. So meanwhile, this submission system has been adopted also by other conferences, ISB and Middle. And one advantage of it is that now we have a database of the challenges that have been organized since 2018. So you can see that if you look at MICCAI, the number of challenge submissions is more or less continuously increasing actually. Main reasons for rejection are dataset quality. This refers to the dataset size, but also to the quality of the annotations. Also poor design choices, or the fact that important information was basically missing. Traditionally, segmentation was the most frequently used task in challenges, but we have an increasing number of also more novel topics, and here you also see that the topic of reconstruction is particularly dominant this year, but more on this later from Annika. With respect to the dataset sizes, I personally was surprised that we didn't, statistically speaking, see a very big rise. You can, though, see that the outliers on the left are more or less decreasing over time. So this is how it all started with this structured submission system. And meanwhile, we have basically started working on all the other challenges out there. And one of the topics that we focused on this year are metrics. In fact, in an international survey that we did in 2018, the community actually requested best practices on how to choose metrics. And we basically started working on this last year to give you some intuition of what we're doing. There's a lot of things that can actually go wrong when you apply a metric. So let's take the DSC as the most commonly known metric, the dissimilarity coefficient. Here you see that if you have a small structure, then a single pixel difference can have a huge influence on the metric. And this is just one of numerous things that can go wrong when you use a metric. So we basically started this picture story of pitfalls of metrics. You see the archive paper quoted here, and this will be a dynamic document. So we will not submit it to a journal. We will keep it running, and the community is invited to contribute. So contact us if you have more ideas. Meanwhile, based on the pitfalls that we're compiling, we are working on actual best practice recommendations on how to choose metrics in a problem-driven manner. This is an initiative actually by the MICCAI Society, the MONA initiative, and the Bias initiative. And one decision that we made was to focus on segmentation, classification, and detection. The reason being that they are very closely related if you look at the metrics, because essentially you can regard them as a classification task at different scales. So segmentation, for example, would be classification at pixel level. So hopefully we will get this done by the end of the year, such that you will have an actual recommendation document on how to choose metrics for your particular problem. Well, once you have a metric as a challenge organizer, or also if you want to benchmark your own algorithm, you have to think about the ranking. This is something that we covered already in previous talks, so I will not go into detail, but we have a recent paper accepted on our open source toolkit for visualizing results. This can be used not only for challenges, but also for benchmarking your own algorithm against other algorithms. Well, we started the research that we did on challenges with the question, is the winner actually the best? And now we move to the question of why is the winner the best, which admittedly is a very tricky question. So we want to go away from the, say, black box result of challenges where you find a winner, you know the scores, but you don't really know what made the winner the winner. So was it the particular network architecture? Was it the way of data augmentation, post-processing, etc., etc.? So what we did is we contacted all the ISBE and MICCAI challenge organizers this year, and luckily all of them agreed to participate. So thank you very much at this point. And we created a survey covering the topics of team composition, compute infrastructure, the software frameworks and tools, the strategy for the challenge. So how much time do you devote on what? And also the algorithm characteristics, mainly for the deep learning methods, but also some non-deep learning based. So now we're entering the absolutely crucial phase. We have several surveys for the individual challenges already running, and please teams participate, because the more responses we get, the more insights we actually get into this exciting questions. You will all be listed as co-authors on the corresponding archive paper that we release. So currently we don't have the rankings linked with the results, but to give you some initial results of the first 15 challenges whose surveys are already open, mostly the teams participating are academic. They work in teams, 20% involving a medical expert. 20% think that the infrastructure was actually a bottleneck. Surprisingly, not everyone used GPU resources. Mean development time so far was 16 full working days, and around 17% thought they did not have enough time for development. But these results are preliminary. They only cover, as you see, 6 questions of the 170 that we asked, but we need, of course, proper time for processing and specifically for linking the answers with the actual rankings. And again, as in our previous work, all of this will be anonymized. So we will not highlight specific challenges, but I look at this in an anonymized fashion. So thanks already for those who are contributing, and we're looking forward to more replies. Last but not least, reporting. I already mentioned last year that we have a reporting guideline released, published in MIA, actually, which should help authors publish their challenge, but also reviewers checking whether the information provided is comprehensive. And the update of this is that we're very exciting to have this guideline accepted by the Equator Network as an official guideline, similar, for example, to the consort statement. So this was the update of the MICCAI Broad Working Group, now the Special Interest Group on Challenges. We really look forward to your feedback, because we basically want to focus on the bottlenecks, on what you think is most important. We will also collect your feedback in a more structured manner, such that we can set priorities. I mean, there's just so much we can do as a team, but again, we really want to support you. And the more you give us feedback, the better we can tailor our energy to what you actually need. And with this, I would like to hand it over to my colleague, Annika Reinke.
Hello, also from my side. My name is Annika Reinke, and on behalf of the MICCAI 21 Challenges team, I would like to present the results of this year's MICCAI Challenges to you. And first of all, thanks a lot to this awesome team with Ingrid, Nicholas, and Spiros for helping me selecting the exciting challenges that were organized this year. And also a big thank you to those challenge organizers that actually filled the survey on their challenge inside so that I'm now able to present the results here. This year, a median of 125 participants are registered for the challenges. But as usual, the number of teams that really submit results is lower. And this year we have a median ratio of 11% of teams that really submitted results. But as you see from the maximum numbers, we have an outlier here, which is the Bratz challenge, with more than 2,000 registrations and more than 1,000 submissions, and more on this later. Docker containers are now the most commonly used submission method, but still half of the organizers that utilize Docker containers reported some issues like many errors in the containers and that it was very time consuming to fix these bugs. Challenge.org is by far the most commonly used submission platform, but Synapse and custom platforms were also popular. When we look at the data platforms, the data hosting platforms, we see a lot of variation here. Most of them using their own cloud, but also Synapse, Lena, and Google Drive were popular. Many others were mentioned, and this is probably due to different possibilities and privacy regulations of the different organizations. But we have good news regarding the data availability. For 88% of the challenges, the training data is available either directly or upon registration. For the test data, it looks a bit different. So for most of the challenges, the participants just shouldn't see the test data. So for nearly all of them, the test data is not yet available or won't be in the future. If we have a look at the concrete number of training and test cases, we see a large variation, especially for the training data, with an interquartile range of 365 for the training and 117 for the test cases. We have a median number of 175 training cases and 100 test cases. And if we look at the plots and also the table, we see again an outlier here, which is the PEDRAC challenge, a sub-challenge of the endoscopic vision challenge. And good news, the training data is also available upon registration so that you can download the more than 7,000 training cases. Unfortunately, cheating occurs nearly every year. And again, 4 occurrences have been reported to us this year by teams that violated the data usage agreement, that probed the validation dataset with multiple submissions, that created multiple accounts to bypass the submission limits, or were creative and overfitted to the test data by using the submission platform of last year's challenge. Most of the team were disqualified, but we hope that this won't happen again, but it's very hard to avoid this situation in total. 69% of the organizers reported that the submitted methods varied a lot in terms of the architecture, but still nearly a third of the challenges that submitted methods were very similar, so that makes it hard to grasp what actually makes a specific algorithm superior to the others. 67% of the organizers state that the winning algorithms exceed the current state of the art, but only 18% say that the problem they addressed is really solved. So we're on a good way, but still there's a lot of work to do here. We have many interesting and exciting challenge organized this year. And due to time reasons, we cannot present all of them in detail. But let me highlight just a few things before we look at some challenges in more detail. Cubic was the first challenge for uncertainty quantification for medical image segmentation and introduced an interesting new type of challenge. Flare does not only focus on the segmentation performance, but also on the running efficiency. And they report that the new state-of-the-art organ segmentation method is very fast and uses only little GPU memory. Hector was the first challenge using PET-CT data and linked researchers that only work on segmentation tasks to those only working on radiomics to work together on an end-to-end pipeline for tumor segmentation and outcome prediction. Whereas Waldo does not only have a super great logo, but they also introduced a new state-of-the-art for detection and instant segmentation for small and rare cases of vascular lesions. And finally, MIDOC was the first challenge that really targeted domain generalization and robustness in histopathology, therefore working towards clinical solutions. Let us continue by highlighting a few challenges in detail, starting with the popular Bratz challenge that has been organized at MICCAI for many years now. It's targeting multi-label segmentation of brain tumors and the prediction of genomic status. But this year, the challenge has been conducted together with RSNA, ASNR communities, and also working with professional evaluation platforms sponsored by Sage Bionetworks and Kaggle. This has led to a very large number of registrations and submissions. So 2,101 teams registered and 1,250 teams submitted a result, which is a very large number compared to other challenges. They had a very large data set, and all in all, this was a high quality challenge. So this collaborative nature of MICCAI, RSNA, and ASNR really worked towards a high quality challenge. And this should also be a blueprint for future collaborative challenges that are reaching this level of quality and attracting many participants from different institutions. They had more than 60 expert neuroradiologists that were recruited to work on the annotations in a transparent fashion. The dataset contained more than 8,000 MRI scans from more than 2,000 patients and is made publicly available. The monetary awards from all of these great sponsors are worth of $60,000. So this is a very successful challenge and a great example for collaborative nature of challenges. Next, let me introduce the cross-modality domain adaptation challenge for medical image segmentation. So this was the first benchmark of this kind for a cross-modality domain adaptation challenge for a large and multi-class dataset working on these problems. This is a highly unbalanced problem, aiming for segmenting brain structures, the tumor and the cochlea, from MRI scans on a problem where we have a large domain gap between the source and the target images. It attracted more than 300 teams that registered for the challenge, from which 55 entered the validation phase and 16 teams entered the test phase. The high-quality dataset contained 105 annotated T1 and 105 non-annotated T2 scans, with additional 32 validation scans and 137 cases for the testing. A large variability of techniques have been submitted, but this was a very challenging task. So 85% of the teams only reached a very low DIE score, and only 5 teams reached a DIE score with more than 80%. So very challenging task. But the top teams shared very similar methods. So all of them used the cycle gun approach with an NN unit and self-supervision. So this task is definitely not solved yet. And we're looking forward to hopefully some future edition of this challenging task. The last challenge we want to present is the first federated learning challenge, so a federated tumor segmentation challenge at MICCAI. They used the data from 59 sites for a federated training phase and a federated evaluation phase, where these algorithms were tested upon their generalization techniques in the wild. They used an open source infrastructure so this was a code challenge to maximize the yield of the developed methods on the use by our scientific community. They used statistical significance evaluation to show which algorithms really work in this federated learning setting. They attracted 125 teams that registered for the challenge, and 14 of them actually submitted results for a very large and interesting data set we have here. So this was the first attempt to explore how federated learning setting actually work, considering data privacy across different institutions. It was interesting to see this working at a MICCAI challenge. Also they had monetary awards of $10,000, and a great thank you to all the sites that were participating in this challenge, and the organizers state that they're also looking forward to the hopefully 22 edition of this, where they commit for 4 times more data from even more institutions that already collected and started to annotate the data. So we're very looking forward towards this challenge and this data set, and hope to see more of this in the future. And with this, before we come to the review awards, we would like to show some graphical abstracts and highlights of some other challenges that submitted their abstracts and team photos to us. So thanks again for listening, and enjoy the rest of the session.